Good evening, everybody. My name is Aneta, and I would like to welcome you for our last talk workshop, actually, on our Living a Better State for our campus party. And I would like to introduce you to Rolf Postel, who will make a workshop with us today. I can't wait. I was waiting for it 2 days.
But yeah, great to hear that. Yeah.
Yeah. We will do microcontrollers and sensor. Do it yourself.
Yeah. Great.
Yeah.
This stuff,
and cables.
fun cables and doing something, and they really do something also. To show you, this one has a light on it. Moment. Yeah. Here's the little. What's the little smiley? It is. Mirror it.
Yeah, little.
Now it's red and something.
Warning.
So things that do something, and we've also something with sound.
This one is amazing.
And this one.
It's amazing. I feel like in the Harry Potter movie. Okay.
It's gone. There it is.
Yes.
Right. Okay. This is why. This is why I do this, and that's the part. Why I'm doing this stuff. This is nerdy stuff, and some people like it, some don't.
It's nerdy but funny. I saw it already 2 days ago. So.
Yeah. I like the eyes always. So the Muppet Show with electronics.
It's similar,
Yeah. So why this drone? This toys for me are inspiration to find out how it works, and I like it because it's small. It's super cheap. In this time, you can buy it for a few dollars on AliExpress, and kids like it. And I mostly
not
want to know.
I think.
Yeah, and that too. So most kids, I like to know how this works and what it's doing. So the toy is the way to find out things, to search for things, and to be creative with technology.
Are you breaking it down and then you're thinking, okay?
No, not anymore. I used to do that in my early days, and my mom and dad were not that pleased when I broke.
You died.
Yeah. So I don't do that anymore. But I know there is probably something in it like this small thing on it, little chip, and this is another one, almost the same.
For me, it's almost the same.
Yeah, it's almost the same.
More blue.
Yeah. This one was sticky and this has holes in it.
Connected.
No, you don't connect it, but they do the same. So it's practically the same, and the small change. But this is a small microchip with microprocessor, and almost every device we have in toys that can react, that are connected with internet, that do something, maybe with your phone or whatever. It has mostly in processor, microprocessor. And what does it do? What does it do? Not much. It can count a lot and very quickly.
It's already something.
Yeah, and it can put pins with power, supply from power or not.
Okay.
And when it's on or off, you can program. Yeah, that's the power, but you can put power on here. And if you put power on it, then it can do something. But you can also give power in, and that's what you can do, for example, with a sensor. This is a sensor. The eyes. These are our eyes, and this is an ultrasonic sensor, and it steers sends a little signal, high frequency signal, and that receives when it reaches an object, it receives back, and then it can measure the distance between this thing and the object.
Okay, so this is like what is kind of using for this measurement for building the walls?
Yeah, probably. Yeah, it's not that secure, but Kind of, yeah, kind of. You see this in, for example, in a lot of toy robots. In the meantime, they see the wall, and then they know if the wall is less than 2 centimeters, I have to turn, and that's what this thing does. Other thing is you see this in parking lawns, from parking garages, from cars, above the cars. But if there's no car, the green, the light is green, and if the car, there's something on it, and so you can see everything. Hey, red, green one. Okay, there is a free space. So it's used for every kind of stuff to measure things. And
because we are in the Netherlands, is it also used for detection of pipes somewhere?
Yeah, you can do it. Yeah, if you need something with measurement, you can do that. This looks a little bit the same. You can steer it also with when you close down, but this is infrared. But it's the same way. It's only with light instead of sound. Yeah, that's different. So my inspiration or my curiosity is in this stuff. I know how it works, and I do a lot in education, and there's only way you can learn something. That's by doing and to be curious in your life. So that's what I teach children too, and we all have smartphones in our phones. Our whole lives are dedicated, and we have all devices that control us, and that's the main goal in the long term. I think kids need to be curious on technology, because if my generation grew up with it in the development of it. I saw every step from no computer and with writing to computers till now. So I'm curious. After that, there was a generation who had only devices that they always worked, or that you didn't have to ask why.
What is that in the back?
Yes, and the latest generation now get the problem with the devices work and they do something, but companies collect data with it. And why is my what's going on with my privacy? And so my kids grew up in a world that not all devices are trustable from the purpose you think they have. And that's why I think you need to take children within the technology and don't get them afraid for technology. Because
to show them what is the purpose of them and how to
a lot of people are afraid for tech. Oh, I'm not techie, I don't know. No, but you steer this. Come on. How do you deny that this is not technology and you're not techie? You have this.
With the knowledge of making a call, but to learn it somehow.
So we have to learn our kids that this is technology and that you have to ask questions and be curious about it. That's the main course for doing this.
So you're making workshops with kids?
With kids, yeah, and this is one for some older kids, and I did it with fathers and sons and girls and too. So it's for everyone interesting, because you can, if you know a little bit of how to do this, you can think about a lot of practice stuff.
Okay.
And it's affordable, very affordable to buy this. That's something I was interested in a few years ago, because I was in the time as a kid. I liked this, but I couldn't buy it. You could buy a little bit of electronics, but this high-end stuff you couldn't get. Only great factories could buy it, and now AliExpress give everything. The whole world.
I see also there's solar panel.
Yeah, there's a solar panel, and I like it. Yeah, there's no solar now. It wouldn't react. It's a little. You see two lights here, and they will. If the sun is shining bright enough, they will go on and off. And this is one of my basics in all tutorials, because this is the first bit of memory in electronics, and there's no computer in it, but this is a computer. This is what the basic of a computer is.
Taking energy from the sun.
In this case, yeah. Because if one of the lights is on, the other one is off, but the one is on, there's no power on it. He remembers, and it's a little bit of battery-wise, it remembers that it has to be on for a second.
Okay.
And that's what we have in our phones in billions of pieces in such small. This chip has billions of pieces of this. And that's what makes for 2 MBs and memory, for example.
Okay.
And you can imagine this one has 64 gigabytes. And then you can imagine so that they now are fighting with a room around the chip parts to get an to use that space too. The vacuum between it's you can imagine it's so big and so small at the same time. So this I use for introduction and to learn get solar and great to do and it flashes and then you can say that makes something that flashes.
Of course, there's always one.
And you need 8 of this part for 1 letter on your screen.
One letter.
Yeah, it's 1 byte and this is 1 bit. This 1 bit is 8 bytes. Yeah, it's 1 letter on your screen. So you can imagine you look to the screen.
That's for it. Okay.
Yeah, so that's an illustration. I like it very much. It's called the flip flop.
Okay, that's nice. Okay. So you have here like a setup.
Yeah, I have some parts. You could order these on my website, CreativeHubs.com. The links are in the campus party page. You can order them yourself. I have the links to AliExpress or in the Netherlands to a few shops who sell them. But then it's more expensive too. You can imagine. So these are the parts, and the nice thing of this part is that you can make. I've made 3 workshops with it, with almost the same parts. Yeah, it's almost this part.
So the 2 before the previous one was also with the same set.
Yeah, and because of the other setting, I thought we talked about in the first session too about it. Okay. What I like to make with you is to make because of the COVID crisis, I thought, I have such a thing, the 2 eyes, and the 2 eyes are for this measuring distance. So can we make a 1.5 meter distance?
Okay.
Yeah.
Great. Let's do it.
Can we do this? So yes, we can. And I give you the tutorial here on my own computer because we can switch. I'm activating the sound now. So I hope you can hear us. That would be great. Let us know if you can't hear us, if someone's listening. And else we have a video from from half an hour with no sound on it.
Yeah. Then we'll just write the.
We have to type after the session. Yeah, great. I give you this part. And this part is called, they are the same, but for now in the instruction I use this one because of the pins, it's easier. So I put this away. And we have 2 parts. Watch this on the, now you can see us doing things on the table here. I think that's nice too.
Yeah.
See, well, a little lower on my screen.
Yeah, I think it's...
What you need before you start is called the so-called Arduino software. And Arduino is a brand. Okay. And for sometimes we call this also some Arduino stuff, but it's not Arduino. Arduino is brand and it's a little more expensive, but they open sourced the software to write code on microprocessors, on all kinds of microprocessors. You can, so Arduino is a nice tool to do this. Okay. That's Arduino. You can download it for free and you can install it. Then you have the Arduino and you have to connect it to your computer. But we do that first at late, and my cable is too short to show it on the camera, but we will find out something else.
We can use
it's not a problem. So we have a piece of code, and I will show you the piece of code for this one. and it's programmed in so-called C+ code. And the code for that is first a define of pins, and the pins are the so-called
These pins.
where you can hurt yourself on. Yeah, okay, those pins.
Okay.
In the Arduino software, you have to tell which board you are using, and you see here almost two different boards.
Yes.
But you have 10,000 different boards.
Okay.
Yeah, all with the specific
I can
stuff
imagine different sizes, different amount of this.
But there's a main recognizable factor on it, and there's on the chip you can see that it's on ESP. Yeah, ESP. It's starting with here.
Yes.
ESP, and this is yeah, and you have an ESP32 is this, and you have an ESP 62. So there are different ESP programmers, and the ESPs are the cheap programmers. You can call them, and you can do all stuff with it. Many people use it for building robots with it. Yeah. We have an ESP. So I told the Arduino that he has to use the software, the downloads, the drivers for the boards from the ESP. And I do that in the settings from the Arduino software. And that's a link you need to have, and you can find it with all, if you look for ESP starting or ESP processor programming or Arduino programming, you can't miss this link. So you need them.
Okay.
And in this case, I have an ESP32, so I have to make the libraries, search for the libraries from the ESP32.
Okay.
So you have to install something before you can start. So this is what you have to do. Then it can find the boards, and then you can program for it. We have some pins on it, trigger pins and the echo pins, and that's why we start with the DIs. Let's call them the eyes. You can read on the eyes.
Should we switch somehow for bigger our screen?
That's great.
This is only small, but this was
that's a good one. That's a good one.
Okay.
If you can read it here, you have 4 pins here.
Yeah.
And one is G and D.
Yeah.
And G and D is also on the board because it's for ground.
Ground.
The ground.
I have it here.
Every power line has a ground and a voltage line.
Okay.
And you every battery too.
First one,
voltage too. V in is this, and you have a 3.3 volt in this programmer. There are differences always. So we have to connect the ground from the eyes to the ground on the processor.
So it's second one, and
in this case the blue one. Yeah. And the other one is the VCC, or the V in, or the V. The V is for voltage, and that's the 5 or 3 voltage. So you can now use the 3 voltage. Yeah, that's okay.
Okay.
So that's mainly always the case in sensors. They have a minus and they have a plus. So you have always those two to connect.
Okay. So
you need power for them. So that's the easy part. Then this sensor has a trigger and an echo. The trigger is sending and the echo is receiving.
Okay.
Yeah. So those two you have to read them. We have defined in the code the trig pin is on 4, and it's in this case the digital 4 pin. And now you have to search in 40 pins. 40
digital 4 is here.
Yeah. You find them. So the trig pin. That's the so-called yellow one in this case. That's nice to have colored wires.
Yeah, definitely.
The D4.
Yeah, it's D4.
Yeah, and the other one, the echo pin, is on D5, and it's I think 2 pins further to the right.
D15. D5. Yeah, I have here.
Yeah.
D5 is the one. Okay.
So if you don't know which pin it is, mostly in the code we define always which pins are used. So you can always read that from the code.
Okay.
Then we have a LED defined, and the LED is a light on it. And in this case, will the sensor react on the LED, and the LED will blink. Yeah,
Okay.
that's what we do. And the LED is on pin 2, but there's a board LED on it, and it's always connected with this pin 2, so you don't need a connection, other connection. But okay, then we have a script. You can make the switch between perfect. Then you have the script, and then there's some setup from the pins. We have a serial called, and that's where you can put data in, and you can read out data from what it's doing now in real time. Because such processor can do one thing. It can only run this script and nothing else.
Okay.
So you have to define, and when you have a long script, it can do many things, but it's one script you upload. It's not such as
you can do more than one. And
in a computer you have operating software and stuff. You can run programs. Now this one is only doing one thing. So this script tells, and that's the interesting part, I think, is the distance part. It's calculating the distance. I have a variable distance and a duration, and there's a calculation for that.
Okay.
I'm not a mathematics guy, and that's my problem in life. I'm creative, so math was my worst scenario on school.
So it's not that if you're good in math, you will go to IT.
No, that's absolutely not the case. It's more practical. Don't hire me for that, because I spend hours on programming, so that's not efficient. But where my efficiency is in the creative thing, so I can connect things and know how to create new things where a programmer doesn't think of, maybe, because that's how my brain works. That's my competency. So there's the distance will be calculated with this calculation. When you study math, you understand this, and you can do something with it. What I understand is an if statement. And I said, if the distance is lower or equal as 150 centimeters, then go blink a LED, high and low, on and off, with a small timer. And the timer is something, I could also say 1.5 seconds or whatever, but I use a timer because I like it much more, because it goes blink faster when you're closer. And it's more reactive than only one blink.
There's like
that's what the timer does.
It's really interactive.
Then we have another else. If the timer is more lower than 150, blink fast. And else between higher than 200, blink between the half second. That's the 500. It's a half second. So it's slower. And else do nothing. If it's higher
than 2 meters,
then do nothing. Don't
so it's like
don't warn
between 1.5 and 2. It's just like
slow
it's
warning.
Okay.
But look out, watch out.
Watch out. But if it's 2, go ahead.
That's probably it. That's the first piece of code we have. And now is the part to upload. And I gonna take it. I don't think you can see it, but we're gonna try to explain it to you.
I can maybe then put this camera here. Let's try.
But I will take a longer wire in a minute, and then we can see that. So we're going to first check the code, and that's the verify button in the Arduino IDE. That's smart to do because you see errors in your code before you upload it. Normally you can put it directly if the code is simple like this, but when you do very complex things, you can broke with some code. You can make forbidden your own access to the processor. So then it's good to check before. So it's checked, done compiling is it, and then I get upload.
You checked on the left side,
checked the check.
Verify.
First I have to check, is the processor online? It had warned me if that wasn't the case, so it is automatically done on my computer now, but I will show you where you can find it. It's on tools, and on tools you see here the ESP32 dev module, And then you can also see there's a lot of Arduino stuff in it because it's from Arduino brand. And here, this is what beneath the line. This is all the stuff you get with the URL I showed you in a minute in the settings. Yeah, that's
but it's like what is available, like what you said.
Yeah,
like
there are a lot of
Arduino,
different processors.
Arduino, but like so they're like also like kind of common.
Yeah, and it's all processor work. Yeah, so and this is the dev module is a common module for this stuff. So it's connected. It's the good board, and it has the good port. Because the ports are important to connect. And it, now it's something like this. It's my Mac calls it this way.
How you know which one is which one?
No, I mostly test.
Try.
I try. You can find out, but mostly I test. Oh, that's that one or that one, and after a while it recognizes itself. But sometimes it's hard to find the right port on the Macintosh because it's not that easy. On Windows it's easier because they have COM ports and mostly you have COM port 1, 2, and 3, and that's it. So that's a little easier. On the Mac you sometimes need some software to do it. So it understands where the board is, and now I'm saying okay, upload the code. And now it's starting to upload, and I will show it some red, and some lines will show up here. Be aware, some boards you have now to push the boot button in. There are sometimes there are buttons here on the boards, and you have to push it in because otherwise it's not uploading, and it gives you an error. Yeah, but I noticed the last updates from the Arduino software a few months ago. I didn't need to do that anymore. So I think there's something changed.
Sometimes it can be.
Okay, it says I've uploaded everything, and it's red. Don't be afraid. But
the color.
Okay, but it's also red if it is a false. But now it says 100% and resetting, and it's okay. So if I I couldn't reach it. I take another USB port. That's the advantage of this. I could plug it out, and I put another cable. It's longer than this one. Then we can show you. Yeah, I forgot
so
my long.
Like needs to, like okay.
No, it's just working immediately. So that one. You can make the camera bigger. That would be great. Yeah.
Is here.
Okay, now can I see? Oh yeah, that's your camera. Okay. Yes. Okay. Can you see the blinking light here? A little darker, huh? Yeah. Now you see the light is off. You see it. The blinking is gone now. And when I point to the roof, and the roof is less than the lamp above me is less than 2 meters. Less than 2 meters. And now I point to you.
And it's super fast.
Oh, get lost, run away! Yeah. So that's the way it works. And you are too close too. You see, you're now too close.
You're sitting
viewers.
too close. You're sitting too close to the computer.
Yeah. And now it's in the room again, and it's more than 2 meters away. So there's no one.
Only controlling threads.
So that's the trick. I like this idea, and then I can think, okay, I can blink a light with it. It's fun. Can I do other stuff with it?
Sound.
Yeah, we can do sound with it. It's the same principle, same process, same eyes.
Yeah.
But the only difference, I've got it here, is the speaker. And this is a speaker.
I really didn't think that you would have it.
Yes, I have it. I'll be prepared. Oh yeah, this one.
Something. Definitely, it's too close. That's really.
I put it here on the table and see it.
That's great. I would like to have it in supermarket, and the people would be so scared.
Okay.
It's
like you're coming too close.
Yeah. Now it's not reacting only 1.5 meter because that's too close
Yes.
to play with it. But yeah, you can.
It's amazing.
People like it, yeah. If you are the player, you like this. If you are aware in the room, then you think, get lost with the.
It's for my hand now.
Yes, it's very close with your hand. It's inspired by an instrument, the theremin.
Yeah.
And that's an electric wave instrument, and you can steer with electronic waves and your hands.
And making sounds.
From the 50s, yeah. And that's inspired by this. And sure, you can put a lot of sounds in this, and you can program the sound better than I did.
Yeah.
But I like the bleeping and bling.
Yeah. It's
this,
like, get away.
This is all here. This is all the 8-bit part music.
Okay.
Yeah, that's also the bit parts.
And now it's far away.
Yeah.
Let's make it like super annoying for our viewers.
Would it detect ghosts too? I don't know.
This one is muted.
Yeah, you can't hear.
This one is muted.
This one is muted.
Yours is not muted.
No. You can hear us, I think.
It's amazing.
Yeah, let's play.
It's really nice.
So that's yesterday I had to explain what a speaker was. They didn't know. They have speakers, but they don't know what a speaker really is.
Okay.
I was a little amazed, but yeah, they were listening to me. Yeah, it's only vibrating electronic stuff, and that's moving the air, and the frequency moving the air is what your ear does drilling, and that's what we experience as music, as sound. Yeah,
okay.
That's how it works. But it's very old. We have it in our rooms, and every speaker is this. This is a small one. You have other sizes. They call DJI and now how you call it now? That's a drone factory. All right. So this is the same principle. I can show you the code. Maybe if you who cares if you're interested?
Oh.
I show you.
It is. No.
Yeah. Arrange the background sound for me. Star Wars. Come on, you can do it.
It's looking like this, you know. Oh, I see you. Lost.
Great.
It's really funny.
I show you. This is almost the same as we did in the previous one. So we have also the LED pin, same thing.
Should I put it?
Yeah. I put the plug out. So how?
I will put it.
Yeah. Yeah. Okay.
Yeah, it's almost the same sound.
Plugged it out because we get crazy here, and put this in for the next story.
Oh, there's light again.
Yeah, that's light. You see the same as distance, and there's something with it now that's playing, and that's the music sound. We define the pins. We have 2 pins, 1 pin exactly with it.
Yeah.
The plus pin of the positive pin of the speaker. That's where the sound goes to, and the other one is also a minus ground.
Okay, so
GND.
it's plus and minus.
Yeah, so I have to define one other pin for the speaker, the sound, to put the sound on. For the rest, is the script almost the same. Instead
I see.
Probably that's why I take you
but
through.
It's like also like high, low.
Okay, we have the distance definition here. We see that. The only difference is the last part, the if else. I removed that because there's no if else. There's sound or not. And here you can see the timer and the distance. This the timer is how far I'm away from it, and the distance too. They make some calculation together, and then there you connect a tone with it.
Okay.
So now I use the variable distance. It's a number figure
Okay.
how far you are from
Yes, from the device.
device,
Yeah.
and connect that to some kind of LED write tone generator, and that's
Okay.
something, a sort of library. It's already in. It can make noise, and
Okay.
that's
So this is what you're
8-bit
taking
noise.
from library about this.
Yeah, it's all it's included,
Okay.
and but when you need nicer sounds and very then you have you need special libraries that are programmed to do this, because the sound itself is not in those libraries, but they use only the basic stuff that's already there.
Beep, beep, beep.
Yeah, the 8-bit sounds. Yeah. So that's basically it. It's a difference. Yeah, those are two mostly the same things, but a total different.
But like,
different.
Different.
Yeah.
What's going on? Because we had lights.
We had lights. Yeah. I showed it in the beginning. That was something else. This is a harder one, because this is a very. I like to show. This is very. What I showed you is very basic. It's part of code. You put it on, and it does something.
Yes.
That's mostly the same. But in the meantime, you like maybe to do more with it, and you want to have control about what it's doing.
Yeah.
And I've thought of a nice workshop also for kids, all the kids. Yeah, from 10 years till 14, 16 years. You have to little bit. It's the range. And that was a shoe, making a shoe of it. Can I show you this?
That can be fun.
Wi-Fi in your shoe. You don't have anything about it, but it's so nice to have Wi-Fi in your shoe. That must be cool.
You need to be
for
connected.
nerds like me, maybe. But you can. This is small stuff. Huh? This is very. It's very little material, so you can put this in your shoe. It's possible.
Is it something similar for what I saw, like clothes with a signal that you're going on bike and you're flipping?
That's
I'm
exactly
going to the
this.
right, to the left.
Yeah, that's exactly this. Although this has, in this case, it has no sensors on it. But you can connect a sensor, for example, the distance sensor, to react, and then your shoes react. You have smart material. It's called Velostat, and Velostat is a sort of rubber-wise thing, thin, like paper.
Yeah.
And when you push pressure on it, it has another resistance.
Okay.
And the resistance you can connect to this, then you have a resistance sensor in part of this.
Okay, and then it's...
And that you can steer, so if you do a piece of Velostat in your shoe and you're walking, then you can say, if the pressure, the resistance is there, then give green light, and otherwise give red light.
Okay, so that's mostly what is like in kids' shoes, which are doing this.
Also something I thought, how's that? That's probably the way it works. Yeah, with some Velostat, and it's nice. If you like this, with clothes and Adafruit is one of the biggest brands who work with smart technology and with good explanation about this, and always with Arduino stuff mostly. And they have an own production line with smart materials and stuff, and there's a lot of things to.
That's nice. It's like really simple then, and it's really innovative from other side.
Yeah, I think, and now how does this work? This is complicated because there's a sort of website running on it.
Okay.
And Wi-Fi. So if you want to do this, you make this as a sort of web server.
Okay.
Yeah, and that's a little complicated. But also I have the code here on my website. So if you download it, put it on.
It's done.
Just the way I work too. Okay. Because I can't, I'm not a programmer. Yeah. I'm not that good. So I find out what I want to make, and I go for search for pieces of scripts.
Copy
paste and put it together. That's not always that simple, but mostly I can figure out, and then it works, and that's what it
copy paste your
it's written so much.
Yeah,
open source, everything you can get. So this is a web server. So it sends out a web address, a Wi-Fi signal where I can go to. And in this case, it's called the Wi-Fi shoe. So I have to connect. That's something I give in the script, named it in the script. So it's sending out a Wi-Fi shoe. Then I go to my browser, and
you're making the
yeah,
color.
we can.
I'll put it closer.
Yeah. Can you see it? Yeah, my light is maybe. Oh, maybe I have to put on brighten my light a little bit. Yeah, now it's there. I think okay. Yeah, and I can push.
I can make it like I make it maybe bigger.
Yeah.
By making this.
Yeah, great. This is something, and I can put here my finger on. Does it see my finger here? Okay. And here you can see the smiley, or you can do red, or the blue one. Now it's gonna blue. We can little dimming.
And then like this smile, you also needed to program, or
yeah, the smiley you have to you have to program because you have
reflection from the lamp. Maybe like this. Try it because I think it's like a reflection from the lamp on your screen.
It's too close. Yeah, it's it's out.
Okay.
Going on.
I can keep this one. Yeah, you can see it.
Can make it dark.
I can just turn off the light.
Smiley in the dark. Yeah.
Yeah.
Maybe you can see. Yeah. Okay. I think so. So the smiley you have to program. So there are libraries for that. Also, it's a Adafruit library also for LED lights. So this is a circle, but you have them in LED strips. You know them from you can program.
Like for instance, like what you have on the ceiling.
Yeah, for sure. So the Wi-Fi in the shoe is a little gimmick, but it means you can put some a complete web page with a web server in such small device and connect something with it, or in this case a light, and steer it with your phone. And so that means you can put maybe a motor on it, and then you can drive a car with it. You can make your own distance, your own car steered by phone. A lot of tutorials you can find with those things.
That's really interesting. I'm thinking like, I'm really like thinking about it. Like now it's about the shoe, but it's really useful for a lot of purposes. Even like I don't know. Even I can imagine that for some disabilities, like changing this color can be really useful.
I've seen it with in connection with some sensors too for people who do not recognize emotions that fast. So you can with sensors in your body you can maybe give a red light or a blue. It's very premature, but you can imagine that kind of stuff with this sensor, with good sensors, and that's what I like about these tutorials. It's not about these tutorials. It's about give people trust that they can do this themselves. And that they starting to think, then I can do this. And that's how it starts.
Then you're starting this, and then you're thinking, how if I would add the sounds to it, or how if it would work in another way, like for instance with Smile, with other.
And you will see, it's very scary. The code of this this shoe. That's not fun for me. Also,
the screen then.
Don't let you scare here. You can download this stuff, so it's always but always it's you see there are a lot of pins you can connect, and you always have to check what the pin states are and what's defined on which pin, because every tutorial
can
use
be
another
pin,
pin,
and then you connect to another.
You have to know that, and that's why you have to read it a little bit, because then you know, this on pin 4. No, I want pin 6. Okay,
so
then
you need to switch or pins or in a code.
Yes, and you can see that. And here's also the LED strip, for example, and this uses the Neo library from Adafruit, the Neo Pixel library. Adafruit is a commercial company, but I think the best for starting in this things, and you get very happy if you see the websites and possibilities and all other stuff, and it's great.
Just dig more and more.
A lot of women work there are the leaders of that group, so I like it very much because that's also an important goal in. No one has to be scared for technology.
It's about basically it's like a stereotype that is like for men and for adults. But it's like
at my home, also my son and my daughter don't like this because that's from dad. Okay. So it doesn't matter if the boy or girl.
So you're convincing other kids, but not your own.
I don't matter. They do other stuff. So
they will go for a workshop to somebody else. They will.
It's always better. Don't do it with your own dad.
Then they will start to like it.
Yeah. So there's a lot of code and there are a lot of scripts in here that define the server. And also this has a particular other part. You have to put on real data on it. So you have to put on a web page, a HTML page on it. And therefore you have some code in the tools. Here you have to upload file, and it's almost the same as uploading the code, but then it takes a piece of code in a directory in a folder.
This one, this one is taken from another file.
It's bigger than the other ones, so it has also a directory with files in it where the website is on. But I don't know if you know about this website. This is Bootstrap, and Bootstrap is a big framework for web building. For web design, front-end development. So I run Bootstrap on a microprocessor from €2. So it's possible. So I liked it. I liked it.
I will look at it.
And then you can design a little bit. Bootstrap is a nice framework for web design, front-end development for designers. Most WordPress websites are designed with Bootstrap, and that's why you recognize everything because. If you don't design with Bootstrap, then it's always the same. So you have to do some effort to make your own stuff. So that's mostly it. In the case of inspiration on technology for some older kids, but I think that there is is the need for education to do this
definitely.
stuff.
And don't be scared and just think like, okay, I can do a little small one like this, and then sound. And then I really like this idea of with shoe, and I think it's really like what I told you. Like I remember this project with biking clothes. It's indicating it's really simple.
That's
in
great.
The end, but it's like creating so much safety then on the road as well. And so
that's mostly it's a good idea. The technique is not that difficult mostly, but a good idea, and there's only way to get those good ideas that you do yourself. You have to build something to see how it works, otherwise you can't think about it.
And be creative with it, because actually I'm thinking, what if you would have this one on bike from right side, from left side, and then it doesn't have to be in your the same like we're using like light for the
and you have wire you can nail in clothes. So and the wire is conductive. So this colored cables you can replace by wire in your clothes, and so you can put it in your jacket or whatever, and you can wash that, and so you have buttons. You can go in the washing machine.
Because that's what I was thinking. What's the way that it's going to washing machine? It's going with this, or you have to?
No, this is not preparable for washing.
This
stuff.
one.
No, and this one maybe, but now I don't think so. You have then you need special
cover or
covers.
Like this.
Okay, but they are. So you can get them, or you can make it with that stick buttons. You click them in the silver. That ones.
Yeah.
You solder the conductive wire on both ends.
Yeah.
And this one has the buttons, and the other one the females and the males.
Yeah.
And then you put it off when you put it in your laundry, in your washing machine.
Oh.
Yeah, there's also then you click off the technology and
click off the technology.
Yeah, it's possible, and you have and I see it. I'm from the south of the Netherlands, and we do carnival there, and I saw always people with a lot of
flashing
lights, and mostly it was for Christmas tree, then in another form. But in the meantime, now you see more people who use this kind of technology to build some patterns and makes the coolest stuff with it. Yeah.
That's really I can imagine. Like it's also like what you said. It's like more available.
Yeah.
So you can start and try, and if you try a small one, then you think, maybe something else, and then you're going for the Christmas tree.
Yeah, sure. Yeah, but that's okay too.
Actually, I'm waiting for like when the Christmas tree lights, the traditional, will just go away, and there will be a lot of this flashing.
There are how do you call it? Wedstrijden. Competitions online on YouTube from the biggest Christmas house collection with lights on metal songs and stuff. You have the Christmas lights house of you don't know what you've seen, and people are crazy.
I can imagine this. People are really creative and crazy. And what you said, like connecting to the sound, is it possible with this simple one? Like for instance, like if you're playing, that it's how it works. Is
there's no real sound card in it. So that there are a lot of modules you can attach that do to convert that.
Okay.
So and the bleeps you hear, it's only the basic stuff in the library, but there are extendable libraries who make nice on and off sounds and waves and so
but
it's
like that you connected with the light, that for instance like light is flashing in the like sounds
and the same as a volume level
so is this
meter. That's possible. You have them. But that's how you find out. You get Googling, and then you see mostly try something with Arduino in it. So VU volume meter Arduino.
Okay.
Yeah,
and then
start, and then you can choose. That's in the beginning is the most hard part is to find the right scripts, because the scripts I made are pretty simple, but when I found them, they were 1,000 times more complex, because so I put on only the basics in it to keep it simple, and most scripts I used for something, and so there's many times there's more than you need for it, but you have to search, and I learned it much from searching the internet, and I saw that I never thought of that. I'm gonna
and I'm going to check it.
I'm gonna make it. So that's my story a little bit.
That's nice. That's really nice. I'm just like thinking if there's something else which I didn't see yet, and maybe.
Yeah, for those, another.
I like this one. This one is my.
It's your favorite.
It's my favorite.
You can have it back. You can have it back.
I would like to go to shop and just like beep, 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 beep. And the faces of people like.
What's that?
Yeah. It's like my private controller. You're too close.
Yeah, of you driving backwards.
And then nobody.
Watch out.
And then
you walk backwards then, and then you peep.
On bike.
On your bike, yeah.
I don't have my eyes. I need sensor. Yeah, that's really funny.
Yeah, that's great. That's great to find that. You can have it back, as do mine. Perfect.
And then I will watch the video, and
I will
make
can
it
go to
myself.
the website. Yeah. You need the website because you have you prepare your computer a little bit. With the Arduino software.
Okay.
So how do you start? You need the to download the Arduino IDE. I showed you. Then you have to choose for the right ESP code.
Okay.
Processor boards, the library for all the boards. In this case, you get for me an ESP32. So you
Okay.
need the library. This is the ESP 8266, but
So
you
there's
need
another one.
this one for the library. And then then you choose the node, MCU, or the ESP32 dev module. That was the one. Yeah. And here's a link to a website in English where someone put complete process in what steps. So if you don't, you watch there.
Okay.
So you have to prepare something, and that's mostly the part. Yeah, that's not the easy part because you have to prepare something, and that's needed on your laptop. But when it runs, and that's cool. And then you can do the workshop. I have a workshop a book here.
Okay.
And you can click on it, and then you get a PDF with all stuff, explanation from many things. I always write more than you need.
Yeah, I see that it's like really step by step.
Yeah, I like that. And how to install here again. It's another explanation with some screen things. You have a lot of sensors for it. You can buy everywhere. But you can get them by kilo. In sensors, you can in big bags.
Really, you're buying by kilo?
2-3 kilos of sensors or whatever you can buy. Yeah, it's amazing what you can do with it. And here in this page, it's really here the connections with the ESPs and on D4, on D5. Just what we do always, and the script, but you can download the script just from here. Download the Arduino code, and then you can put this on your open in your own Arduino, and flash it on your
in my window.
Yeah, let's find out. Call me if you. I will help you on distance, no problem.
That's serious. I can imagine that you can help with the distance because we're also doing this on distance.
Yeah, I have some chat in this thing. So mostly I've done it with the chat room, and then I invite people to chat with me, and then we can do a video chat. And normally, and that's because the Wi-Fi, I need the connection for my internet now. But normally I have a smartphone. Yeah. Here it is, and I can make my cam an IP cam, and then I can open my browser and put the IP address, and you can see it then.
Everything.
But it was not possible.
Yeah, I'm going to try.
Great.
Where is this? Here.
The CreativeHubs.
CreativeHubs.
Go find it on my page in the Campus Party webpage.
I will text
the links are there.
Here in the chat.
Yeah.
Or maybe just like I will make a banner if I'm able. Let's try it.
Yeah, we can a little higher. Can people see our heads? I don't know what they've seen, but
yeah, they see us. I think enough. I'm going to do here.
Yeah, if you have questions, I don't know. Someone looking.
Yes.
But I can imagine you do something else on Saturday night.
Create a banner. So we're going to do CreativeHubs.
Hubs.nl. Yeah, and from there you get a pop-up. But it's I'm sorry, it's a Dutch website because all my clients and all my schools are in Dutch. Hubs, yeah, it's okay. It's okay. So that's let me know if you need something in English. But
now we have double screen.
Yeah.
Okay. Here.
So I see there's no questions. Yeah, you have to start for yourself. It's great.
Yeah.
You see the fun here.
Yeah. Definitely, you have to start, and then I don't know where to talk.
We don't know.
We're on both
two laptops now. Yeah.
Let's remove one.
We are immersive. Here. Immersive view. Yeah. Okay. Hello.
Hello.
Did you see this the whole time? For sure.
Maybe. I was going now. Yeah. Maybe yes.
Yeah. Okay. Then you see the hardware. Yeah. Okay.
Yeah. Definitely go to check website, and then you can also order this set.
Yeah, and the links to order it yourself, it's okay, but you have to wait a little longer because. But I don't. I only send in Holland. I'm sorry, I don't know. It's maybe I can't send it to South America or whatever. It would be very big to do.
Yeah.
Difficult.
So only in the Netherlands.
Yeah, please.
Okay.
Please.
Thanks a lot, Roel.
thank you
Yeah,
very
thanks.
much for
I'm going
giving
to-
me the stage, and
Yeah.
I hope you have enjoyed. We enjoyed it a lot.
Yeah, I enjoy it, and I'm really going to
do this.
do
Okay,
that
great.
again.
Thank you very much.
And maybe I will come for the one workshop for kids.
Yeah, great.
I don't have a kid, but yeah. I think that I can enjoy
The
it as a
adults
kid.
play the most.
Yeah, I think so. It's the same like always. Like adults are going to give the toys because they like it more than kids, and then the kids are happy. But but
make the kids curious. That's the
Yeah.
most important thing.
Yeah,
They
I
don't
think
have to build, but
definitely.
make them curious. For
curious,
tech.
and then even like they will start to build this one now, and then in 5 years they will think, something. Yeah, I think creativity. This is like the missing part in every kid's education. Always,
great,
always.
great.
Yeah. Okay. Thank you a lot.
Great.
Wait,
And
I'm
then,
tapping here.
Yeah.
Okay, so it took 1 hour. And thank you everybody already. That was like our last session. And please comment us, please open again the files. And if you have any question, you can always email to Roll on the website. And we hope to see you next year. Yeah, see you next year. Thanks a lot. And oh, this one.